Welcome back everyone to this discussion on group by operations, along with a discussion on the multi-level index in Pandas. A group by operation call allows us to examine data on a per category basis. So that means being able to answer questions like, what's the average per group or per category? Or how many rows do we have per category? So let's explore what this looks like in Pandas and what we mean when we talk about per category. Here we have two feature columns in this so-called data frame. We have a category column and a data value. And so when we're performing a group by call, essentially what we want to do is aggregate a continuous value per category. So here, the first step is to choose a categorical column to call with group by. And categorical columns are non-continuous. Essentially means that you have distinct groupings. So this category column has three distinct categories: A, B, and C. Unlike the continuous data value column, where we can see it's just some sort of continuous numeric call. Now, often beginners are confused and they think that categorical columns must be a string column. While it's more common for them to be string columns, keep in mind that they can actually still be numerical. So for example, the cabin class category on a ship or a plane, like first class, second class, or third class, those could just be represented as numbers 1, 2, and 3. Another example could be the model year for a dataset consisting of cars. You can have the category of 1970, 1971, 1972, and so on, just different years. So keep that in mind. Once you've decided on the categorical column, then what you do is you call a group by call on that, and it has to be combined with an aggregate function call. So what we do here is what Pandas is actually doing under the hood is it takes in your data frame, and then once you decide on the category to group by, you essentially separate out all the other columns by the distinct categories. So we have all the data values for A, B, and C here. And then you decide on an aggregate function. For example, if we call the sum aggregate function, it's going to take the sum per category, essentially summing up all the A values, B values, and C values. So you can see the result here for A is 10 plus 5, 15, 2 plus 4, 6 for B, and then for C we have 12 plus 6 is 18. You could call a different aggregate function, such as the mean, so then it grabs the average value per category. And then you can have something like the count, essentially asking how many rows are there per category. This is different than sum because it's just asking you to count the instances per category. And in this case, they're all the same. There's 2 rows or 2 instances per category. So note that in Pandas, calling just group by itself creates what's known as a lazy group by object because it's waiting still to be evaluated by an aggregate method call. Let's explore this all further in Pandas in a Jupyter notebook. Okay, here I am in my Jupyter notebook. I've already imported NumPy and Pandas, and the data set I'm going to read is located within the Pandas folder. So we're going to say read CSV, and it's called mpg.csv. And this data set just has a bunch of information for lots of different cars: the miles per gallon, number of cylinders in their engine, displacement, horsepower, weight, acceleration, and then there's a model year, an origin number, and then the name of the actual model of the car. So what we're going to do is let's go ahead and start exploring how maybe performance has changed for the cars throughout the years. You'll notice that we first have to decide on what's the categorical column. So categorical column here could be something like model year. We have multiple instances of various cars per year. So maybe we're trying to answer the question, how has performance of miles per gallon changed throughout the years? So we could say, go ahead and grab the average miles per gallon for the years, like 1970, 1971, 72, and so on. Okay, so keep in mind this does take a little bit of knowledge of your data set to decide on what is a categorical column versus a continuous one. Another example of a categorical column here could be something like cylinders, because it looks like we have multiple instances of 8-cylinder engines, 4-cylinder engines, and so on. An easy way to check for this is to do something like, for instance, model year, and you could just ask for the unique values here, and you could see that there are multiple instances of 70 based off what you see in the actual series, and then you can see there's unique here. You can also do something that we've done before, which is value counts, which goes ahead and gives you the actual number of rows per category. This is kind of a very fast group by, but we'll show you how to do this manually in just a second. Okay, so we decided on our categorical column, which is the model year column, because I'm trying to answer a question like, how has miles per gallon changed on average per year? So then what we need to do is say df group by, and then you're going to group by and pass in what you want to group by. In this case, it's called model year. Now I did mention that group by objects are lazy, and that means that if I just run group by model year, I get back this group by object. And what this means when I use the term lazy is Pandas hasn't actually done any work yet because it's still waiting on performing the calculations from the aggregate call. So it's still waiting for you to say, do you want the sum per category, the mean per category, etc. So what I can do here is say call.mean, and keep in mind there's a list of all the aggregate method calls in the Jupyter Notebook as well as in the documentation. So if we take a quick look at the Jupyter Notebook for this lecture, if we scroll down here, we see the group by method. I have a list here of all the most common options of things you may want to aggregate by, as well as the link to the documentation on this. But let's go ahead and back to grabbing the mean value per model year. So note what this is doing. Suddenly, the model year is now the index. So what it's going to do is it's going to grab the column you want, it's going to group by that particular category, set that as the index, and then it takes in the aggregate of what it can do. So if we come back here, you'll notice, if we say df, we had a name column, and there's no way we can take the average of things like Chevrolet, Buick, and Plymouth, etc. So instead, it just doesn't bother to return that column. It's going to return back pretty much the numeric columns that it can perform a mean aggregation on. So here we can see MPG. You'll also notice that this is essentially a data frame that's being returned here with a named index. So if I was only interested in MPG, I could then, simply using brackets, grab the MPG column off this returned data frame. And so now I can see the average MPG per model year. And you can see that in the 70s, it starts off 17, 21, 18. But as you move further in time through the 80s, the miles per gallon starts to get higher, which is just a general trend that miles per gallon has typically gotten higher over time. Obviously, it may depend on the actual type of or model of car. Speaking of which, sometimes you want to actually group by multiple columns. So I mentioned that maybe miles per gallon is different by type of car, such as the number of cylinders in that particular car's engine. So what we could do, instead of just grouping by a single column to get the average, what I could also do is group by the number of cylinders as well. So technically, I could say df group by, and then pass in a list. So I'll first group by model year, and then after that, I'll group by the number of cylinders. And then let's calculate the average value there. And notice we start to have what's known as a multi-level or hierarchy index, meaning model year and cylinders are not column names, and this is displayed to you by the fact that they're on this second line. The columns I currently have in this data frame that's being returned here are MPG, displacement, weight, acceleration, and origin. And we can confirm that by simply calling columns on the return data frame, and I see MPG, displacement, weight, acceleration, origin. However, if I take a look at my index, I have two levels of an index. I have this model year level, and then the cylinders available for that model year. So it's grouping first by model year, so 1970, and then per cylinders. So I can see that the 4-cylinder engines had higher miles per gallon than the 8-cylinder engines. And then I can actually now start doing a comparison, not just per year, but per cylinders per year. So now I'm kind of adjusting for multiple categories, which makes sense because then I could do things like just compare 4 cylinders from 1970 on average to, if we scroll all the way down, 4 cylinders in 1982 on average. Again, higher. Okay, so the thing to keep in mind here is this has returned a multi-level index. So if I call index, I see here that it's trying to say that it's a multi-index with these tuples. So there's the outer index of 70 and then 4 cylinders. Then there's another instance of 70 with 6 cylinders, 8 cylinders, and so on. So let's talk about how to deal with and work with something that returns back a multi-level index, because it's going to be a bit trickier to try to grab something like MPG just for 1970 with cylinders of 6. And as before, I could just grab every instance in a column by saying something like MPG. So again, now I have this kind of multi-index series here. Okay, so before we move on, I just want to quickly also show you that instead of just calling mean or sum at once, you could also do something like describe, which is df group by, let's go ahead and just do model year. I could say describe, a method we've seen before. And so what this does is it shows you everything here, miles per gallon, the count for that, mean, standard deviation, min, percentiles, etc. Sometimes it's easier to read this if you transpose it, as I've mentioned before. And so what this does is it returns back this slightly complicated data frame, but it essentially shows you all the aggregation methods possible for a single column. So if I was interested in what is the average miles per gallon for 1971, I would come to 1971 model year, miles per gallon, average, and it's 21.25. I can also see the minimum miles per gallon value as well as the maximum miles per gallon value for each of these years. So just something to keep in mind in case you want to just quickly grab some statistical analysis of a data frame. But I mentioned that we kind of want to focus on this idea of this multi-level index and then how to deal with this multi-index object. So let's say year CYL for cylinder is equal to df, I will call group by, and again we're going to group it not just by model year, notice I'm passing a list in here, but also by cylinders. And then let's just grab the average value just so it's not overwhelming. So now that I've assigned this to a data frame, I can take a look at it. And here's what we had before. Essentially the average of miles per gallon, displacement, weight, acceleration, origin, etc. And then it's the average not just per year, but also per cylinders. So we just explored the index, and I can actually grab the index names, which is model year and cylinders, by calling .index.names. And this reports back model year and cylinders. And this can also then report back the levels available. So if we say index.levels, it gives you the outer levels. Notice it's a list of lists, multi-dimensional array here. And we have the levels for the outer level index, which is the model year, and then the possible cylinders. Essentially showing you all the possible years and all the possible cylinder values. Keep in mind, not every cylinder value is present for every year. So there are no 3-cylinder cars for 1970, for example. Okay, so let's talk about now working with this index. What I can do is I can grab based off the outside index using .loc, just as I could with a normal data frame. So if I have this year cylinder, and let's go ahead and imagine that I'm only interested in grabbing on this outside model year for the year 70, I can simply say .loc 70, and the .loc commands are going to work in reference to the most outside level index. So then this returns back the values for 1970. Keep in mind it just drops that outside level index, so then you only see cylinders. What I could also do is then pass in a list here. For example, I can then say, okay, give me 70, comma, and then also, let's say 82, the last year value. And since I'm asking for more than one year in order to distinguish, it's going to include model year as the outside level index here. So then I could say, okay, let's check out cylinders for 25 miles per gallon versus in 1982, cylinders for 32 miles per gallon. So .loc, it's going to work on this outside level index. If you only wanted to grab a very particular row, for example, let's say I want 8-cylinder cars for the year 1970, then you're going to say year cylinder .loc, but then you're actually going to pass in a tuple. And the tuple essentially corresponds with the output we saw earlier when I called .index. Notice there were these tuples here. Well, all I would need to do is, for example, grab one of them, like 4-cylinder cars for 1970, and then pass it in here, and it returns back that exact row as a series. Okay, I'm going to stop it right here, and in the next lecture, we're going to talk about grabbing based off a cross-section. So right now, I know how to grab things based on the outer level multi-index, or based off an exact row. But something I don't know how to do yet is grab every 4-cylinder example for all the years. And what we're going to do is learn how to do that with the .xs command, which is a cross-section. And we'll talk about that in the very next lecture. I'll see you there.